Hello and welcome to Kanecki Associates IP briefing. For this briefing, I'd like to discuss some products that we have for sale that can help various companies in your company. We're planning to auction our IP software on October 10th. And what we're doing is we're going to do sort of a Swiss bid. So we're asking people who are interested in software to either contact us on Twitter at our Kanecki Associates site to receive additional information like a product catalog and a prospectus. And for those that really want to bid, to submit a bid to our corporate mailbox at P.O. Box 866, Kenosha, Kenosa, Wisconsin 53141. Again, Kanecki Associates. At P.O. Box 866, Kenosha, Kenosa, Wisconsin 53141 by October 10th. The top 5 highest qualified bidders will be selected, and in our prospectus we will list what we expect is a minimum bid that we are hoping for the software. With the IP that we have, what we're planning on doing 2 ways. One is we're open to basically selling the entire portfolio that we have or parts of our portfolio. If you should buy just part of their portfolio, then that means that basically there will be a higher cost, because since you're just buying one, to make sure that we get a certain bid value. Or if you're buying multiple parts of their portfolio, we'll give you a discount. Now, just to give you an example what some of the portfolio is, like in my description there, I have gaming, artificial intelligence, neural network, business intelligence, database management, RAD. Now, let me go through all of those, or some of those. Like one of our programs that we have, which we're world leader in, is intelligent thinking systems. The program was originally developed in 1990 using Turbo Pascal and has been maintained and further developed throughout the years, going into Lazarus and using Embarcadero RAD 10.3. The advantage of ITS is that ITS allows you to simulate what-if situations, but it's not what-if what you would think is like, even though the program was presented using a chess motif, it's not limited to chess. And I say it again, it's not limited to chess. Because what it is the way the program works is, I'm always interested in thinking about how far or how well can we get a computer to simulate like a biological process. Because the joke in AI is that, we have all these advanced computers, but yet we can't write an AI program that can simulate the brain of a grasshopper. Well, what I do with ITS, I sort of say, well, okay, let's see what we could do to try to simulate human cognition by a computer using neural network techniques and artificial intelligence techniques. Now, the way this differs from something like Big Blue or something like this is basically Big Blue and other programs do what's called a massive database search. Like if you want to solve an option, it goes to a database. It goes, okay, let's start here, go to this tree node, go to this tree node, go to this tree node. Go. Now let's see what they're going to do. Start here, go to this tree node, go to this. And it'll do this like, very, very high depth. Now, my feeling about when I started the ITS project is that as human beings, we don't think that way. We don't think every time we do something. Let me just get a visual pop here. Like this is one company I like going with, and we don't think every time we do something, make a decision, we don't go like, well, let's see. Well, page 2 looks good. Page 19 looks good. Page 39. Oh, there it is, page 55. And then we go to another move and go, oh, let's see, 3, 15, 23, 37. We don't do things that way, because basically what we do is when our body thinks and our brain thinks with the 12 ganglia that we have, basically that controls them all: seeing, smell, touch, feel. the reaction, like if you were to put your hand on something that's very warm, the autonomic reaction snaps your arm back. So that when I developed ITS, I developed it with that sense that basically your body doesn't use the database, your brain is there, but what happens? There's certain functions that are autonomic, and some functions they're not autonomic. And so I wrote a program to do that, and I modified this program to do work in other areas other than chess. For example, you can use it for spaceship control. You can use it for industrial control, business decision making. Basically, different types of autonomous vehicles, other things. And what the main issue about this is when I developed ITS is I developed this as what happens when it's playing. The reason I use the chess mouse is I use the chess board as a metaphor for how we interact with our world. Because, like for example, we see if our eyes are closed, if I want to find the mouse, what will I do? Feel on the table. There we go. Got the mouse. Or if I want to find the microphone, my eyes closed. There we go. Got the microphone. And that's how we do it in a dark room. We don't have a database that says, well, do this, do that. We feel alone, and that's how ITS works. It works like the ganglia in our brain. It feels alone, but then once it feels alone, then what it does is I set up a different type. I didn't use a database. I used what's called a form simulating the synaptic neurons and how synaptic neurons in the brain. Because synaptic neurons in the brain are not organized like computer records. Like you have one record here, another record there, another record there, another record there. You think of it like the HAL 9000 with the sliding cards. Really, what it is the way our brain works is you have different neurons that connect to each other like this, and also some that connect like this, and eventually what happens, they sort of form like a little bit of a network. Some are connected, some aren't, and that's so what happens by using this approach. Decision making is done in a way that emulates human behavior and human cognition, I think, to a better level than traditional database programs like Big Blue as a chess program. And the way that why I think this is better, because the other point I did where I took it one step further was I said, well, in my other studies, I said, well, is it possible for me to emulate different types of people's styles on how they play, without significantly modifying the program? The only thing that's modified is the neural network map that's used in the program. And I found out that I could do that. And what happens, I was able to simulate various people, grandmasters, other people, and even I could even simulate myself by going back through games when I was younger. Like one game, when I played, looking at some games I played in '77, and other games I played in '91, and I could actually see how it would simulate how I played back then. And later, what I did, in addition to ITS, I developed a neural analysis module. So basically, you could take a neural map of the ITS module, and you could run it and compare it, and it'll tell you, oh yeah, this neural map is equivalent to this type of strategy, or this neural map is equivalent to that type of strategy, or this neural map is equivalent to this type of person or that type of person. And you could actually tell basically overall, who this is equivalent to, or even moment by moment. So it gives a lot of insight into how decision making is made, and basically what type of decision making person or strategy is used. The last point of the analysis, I went into a point of saying, well, now that we got this about figuring out who or when like this, what about, can we simulate this like the way you see it on basically an EEG, electroencephalogram? Basically you have the pulses and goes, different. And that's why I developed a method to actually take this neural map data and actually use a method to actually be able to simulate the sinusoidal rhythm that you would see in the EEG to sort of be able to actually generate an EEG, so you could actually compare that and almost get like a virtual EEG by having someone use the ITS process. Now, this program, like I said, has been converted over the years. It's actually been converted into more than just using the Western mouth chest. It also was converted early on in 2001 and 2003 into using the goal model, the Eastern model, as I call it. And I called that AlphaGo. And what happens is I also developed other versions, Beta Go, which was involved 3 players playing at the same time, and Theta Go, which involved 4 players. And with Beta and Theta Go, you could actually form alliances. You could have like 2 players forming against another player, or you could have 2 players going against each other with 1 player being neutral to either one. Like I said, different alliances, different ITS profiles. And all this was done using, like I said, basically at that time was Delphi, and then later Lazarus and Embarcadero. All this source code is maintainable. It can easily be adapted to any business need, any scientific need. We'll put more additional information in their perspectives. Now, another program that we have that we're willing to sell on our IP is what's called MIAS, and that's an acronym for Medical Imaging Analysis System. We developed this program to analyze basically scans, so cranial scans and abdominal scans of cancer patients. And we did do a phase 1 study with a local hospital where that study was successful and it passed. We had a very high accuracy rate, over 95%, and also we had very low inaccuracies or false detections. And the thing is, this program, again, was developed originally in Delphi. It's been modified to Lazarus, also modified using Embarcadero. Like ITS, this program has been ported to multiple operating systems. For those of you who like Linux, those who like Windows, those who like Mac, it's all there. And also the code is written in, all of our code is written in plain vanilla, because basically we're trying to write it so we have the maximum portability. So it's very easy to update, modify to your system. And even if you don't want to modify, you could actually use that to link into a hospital system. The advantage of this code, though, is compared to other codes, this code does not directly link into an MRI machine. The main principle is that any data that you get from the MRI machine, you transfer over to a different source. You transfer it over to a USB drive or something else, and you put the USB drive. There's no direct connection. And part of the reason we did it that way was to get around the FDA restrictions about if you have something that does directly connect to medical equipment, there are more testing and rules that you have to follow. This one basically circumvents that. And for some people who are looking to buy this program that are outside the United States, Canada, EU, this program would work in your systems without any modification or any special rule exception needed for your medical societies. And the same as in the U.S., but it'd be easy. It's easier in those. So that program involves, it can analyze an MRI quickly, and if you have a set of MRIs, it can analyze it and it can tell you pinpoint spots as where the cancer is. In addition, it can do what's called a differential analysis. So let's say you have a time-based MRI slot, of a patient. You have a patient came in maybe October, and you took many MRIs before then. Well, this program can actually pinpoint and actually can tell you how big or how small is the tumor increasing or decreasing. And it can give you a very precise measure of the mass of this tumor. So you can actually do a quantitative analysis to figure out what the rate of growth is or what the rate of decline is. A third program we have is what I call Kanecki Prolog. Now, Kanecki Prolog is our software program and IP that competes against Watson. We don't have the visual interface for it, but what we focused on the internal processing. One example that we use Kanecki Prolog for to demonstrate how fast it could solve things is we took a cancer marker database, and what happened was we wanted to see basically, well, okay, we have the database. This marker links to that marker. This marker links to that marker. This marker links to that marker. It's a big database. It's when you print out the file, it's a huge number of pages. So we wanted to say, well, okay, now what about if we could find actually what's the whole network map? How does everything link in the network? So we ran the Kanecki Prolog program. We coded the files so that it could process by Kanecki Prolog. And what happened, we typed it in, loaded it in, 1 Mississippi, 2 Mississippi. It calculated the whole map of 65,000 epitopes in 2 seconds. And we are to print this map out. When you print this map out, just to give an example, if you were to print this map out in hard copy, you would have something this thick. And that was done in 2 seconds. And it was done with Kanecki Prolog using very simple commands, but very complex processing on the inside. So this program is available as well with the IP source code. We are, as you probably have guessed, we are basically a Pascal Delphi Lazarus shop, and we do prefer to, although we do have some IP that we've converted into Java, like the MIS, we converted into Java, the Prolog, we converted to Java. On the ITS, we haven't yet, but we prefer just to stick with basically Delphi-like languages or Java. So that means like Delphi Lazarus and Barcadale or Lazarus or Java. And what we do is when we use Java, we normally use Java Standard Edition or Java FX for our IP software. We can put that all in the portfolio. What I like to just remember is we're looking for principal bidders only, and we're looking for basically principal bidders who understand the software that the IP that's being sold, and that's why we'll prepare a detailed prospectus. And remember, the date for submitting a bid is October 10th to Kanecki Associates, PO Box 866, Kenosha, Wisconsin 53141, United States. And Kenosha is spelled Kenosha. Again, Kenosha. So Kanecki Associates, PO Box 866, Kenosha, Wisconsin, Kenosha, United States. And on October 10th, we'll open a bid. We'll contact the top 5 qualified bidders and expect to close on the bidding with one of the top qualified bidders by the end of October. So let us know what you think. And also, I prefer any messages or anything else to be left at the Twitter site, as it's easier for me to manage messages from the Twitter site of Kanecki Associates. Thank you again for listening, and there'll be more updates to come.